Hello everyone, welcome back to another video. In today's video we'll be going through txtai. It's an all-in-one embedded database for semantic search, LLM orchestration and large language model workflows. If you don't understand these words, semantic search is a search engine of sorts which is quite intelligent that it searches related words. LLM orchestration simply means that it can work with different LLMs doing completely different tasks. And large language model workflow simply means that it's able to handle workforces from different large language models to get a common task achieved. Using txtai, we can do a lot of embedding based, data based, vector indexing and similarity search, differential search, topic modeling, etc. What is the big hype about embeddings after all? Text embeddings or word embeddings are a model of extracting features out of the text so that we can use this text for features into a machine learning model to work with text data. They try to preserve semantical and syntactical information of the word itself. Under the hood, before any word embeddings occur, the words are tokenized. I can show you a small example of how tokenizers work, but this is off topic, hence I'll be showing a very quick bunch of things you can do in Python. You have NLTK library in Python, which simply means natural language toolkit, where we can do a bunch of natural language programming. To start off, we have a string here. To start, we can use NLTK to get all the sentence tokenizers, something like this. And if we print it out, we get a result something which looks like this. Here, even though we had given one single sentence, you can see there are three different sentences. So the NLTK toolkit was able to figure three sentences of the given single sentence. Most of the time sentence tokenizers are useless because they are way more generic as they are working with sentences rather than words. To get the word tokenizer working, we will need to call NLTK's word tokenize and give it the string as we had given it for the sentence tokenizer. We can do much more using the NLTK toolkit, like lemmatizing and stemming. They are methods where we can break or stem the words to its root form. There is an example of lematizer on screen. However, I'll be showing you how we can do stemming in detail. To call a stemmer with nltk.stem.lancaster stemmer. This is a constructor. We should have a list comprehension where we call each of the words in the above sentence using this stemmer.stem method, where we pass each of the words from the above NLTK word tokenizer, which looks something like this. We can print the value here, the list comprehension val, to get the difference of the word tokenizer and word tokenizer after Lancaster stemmer processing it. One last thing before we conclude our NLTK toolkit is something called as POS tagging or parts of speech tagging. NLTK's POS tagging method will give us different parts of speech in the given sentence, which accepts either words, or we can give the whole iterable to it and it will figure out the parts of speech in each of the word as per the sentence. So you might be thinking, how or why will be this useful to us? That is where word embedding comes. Word embeddings will be able to group like-minded words together in a vector space in an n-dimensional space. This will help the word embeddings to understand the word quickly and give search which are more generic and then express itself with different words together and make sense out of it. Word embeddings are generally stored in a different or unique kind of database called vector databases. Some of the popular vector databases which are available are Milvus, Quadrant, FAISS, which is Facebook's, which we'll be using today actually, and Elasticsearch, OpenSearch, etc. So what really can you do with these word embeddings? Quite a lot actually. In today's video, we'll be focusing on similarity search, semantic context-based search. If you quite don't understand what that means, it simply means it's kind of AI-based search where you give a vague sentence and the computer will magically understand what you mean and give search results based off of it. To start off, we need to install these libraries, majorly txtai and pandas, post which we can start writing the code. I have a bunch of code here which really you don't have to write, which is just saying where Hugging Face hub to download the large language models, which is actually in this location right here. You don't have to write this. This is actually making my code less optimized, so I'm just hiding it out. The next thing what you'll have to do is form a data frame, which is reading the pandas CSV file here using pandas.readcsv. This is quite a small data frame containing only about 11,000 values. Hence, the training of this is quite quick compared to the other one, which is Amazon products, which we'll be doing later in this video. Now it is time to start writing the embedding logic for our text. We can import the txtai module and start with embeddings using this txtai.embeddings. You have a small embedding, small e embedding. You will have to actually use the capital E. If you have an IDE like PyCharm, you can actually see C, which means it's a constructor. This constructor takes in a module. Any compatible module from the Hugging Face will work. However, here I'm using the default one which they have used in their example. You can play around with this module to get best results out of it. To have anything working for this embedding, you will have to index it. You can give any iterable in the form of documents for which you are indexing. Here in our case, we'll be using the uses in our data frame, which basically says why the medicine is used for. Once that is done, we can save our embeddings using embeddings.save. Here you can give a path where you can save the embeddings, or you can also, if the embeddings end with .zip or .tgz or tar, in those cases the index will be stored as a compressed file. Once that is done, if you run your code, you should see a folder called saved modules with the modules that were saved. I am writing a separate file for loading the embeddings which we had just saved. Realistically, everything should be in a single file. However, it makes my demonstration easier. Here in the load method, almost all the code gets reused. However, instead of saving the module, we are loading the module and giving the same path where the module is saved. Once the module is loaded into, we can do embeddings.search, for example, to search for a particular query and get results for specific query. We can also limit the number of queries we get as results. Now let's see how embeddings.search gives us results. Now I am going to query for knee pain. Let's store this embedding search in a variable. As you can see, we get IDs and the actual location where the embedding results are stored. This is quite not useful for us in such a way. Hence, we will have to intelligently print out the formatted results as per our requirement, which is quite actually easy. We can use the Panda data frame's iloc method to get the indexed location of that specific row which we are looking onto. Now let us see how the results come out as. Now just to emphasize, I had just given it as knee pain. Now let us see what the results are. We can see the results look something like this. Even though these set of outputs which we are getting had nothing to do with knee pain, the module automatically analyzed and gave us these results. We can expect different results for different phrases. Let's give knee pain as a single word. Here we got a better result of arthritis treatment. Hence, we can say this is really understanding what the query is and giving us a search result, not just searching for a specific word. I have another module saved for Amazon's product history of 2023-2024. This module is, however, really quite big. As you can see, this is the medicine details, which was about 19 megabytes. However, this Amazon product module is about 900 megabytes. Let's see how the data frame looks like. This data frame has around 55,000 rows. It has names, the main category to which the items belong to, a subcategory, the image itself, it's a URL for the image, the link is the actual Amazon link, the ratings for that, number of people who have rated, the discounted price, the actual MRP. Now we can use similar techniques what we used for the medicine to generate for the Amazon products. In our case, we will be embedding indexes for names, as we have majority of the information in the Amazon product history page for the field names. We would have done the indexing and saved the module in a specific location. Post doing that, we can load it with the same location where we had saved it from. However, as you remember, we will not get the actual data in the form of formatted text. We will have to do it ourselves, which would look something like this. Let's query for gaming laptops, why not? Now let us see how the results look like. Remember, we had given it for gaming laptops. Well, even though we gave it for gaming laptops, the search history we got is for backpacks. These kinds of stuff do happen, and training with a better model will help in such cases. However, they are not really bad. As you can see, one of the results which we actually got is a laptop itself. Let's search for gaming PC high performance and see how the result come up. Right off the bat, you can see he is suggesting he is suggesting items which do not actually really match with the query words itself, because he is thinking and then understanding what it actually means using that vector database and the word embeddings itself, what the closest output he is figuring out using this query results. This is a non-modular power supply and it has a high performance somewhere in its description, but even though it does not have anywhere high performance in its name, he is still suggesting us this power supply, which is really good if you think about it. Now let's give like an actual ideal search and look for results. Now we get to see good kind of results. As you can see, we have Lenovo computer being suggested here. Quite realistic for what we have going on here. And as you can see, there is no keyword gaming in this entire search result which he has given, but he knows 11th generation Core i5 is a decent enough gaming PC, and hence suggested using only the word embeddings what we had given, and the model is able to predict a good result for this query. Thank you for watching this video. I'll have all the code listed down in the description if you want to play around to yourself. Anywho, thank you so much for watching this video and have a nice day.